हेलो गाइस, आपका स्वागत है हमारी यूट्यूब चैनल शिव एकेडमी ऑफ मैथमेटिक्स के अंदर। तो आज हम पढ़ रहे हैं वेक्टर कैलकुलस। तो वेक्टर कैलकुलस के अंदर हम वेक्टर्स के बारे में डिस्कस करने जा रहे हैं, जिसमें ग्रेडियंट, डाइवर्जेंस और कर्ल, ये तीन इंपॉर्टेंट टॉपिक्स हैं। तो वन बाय वन हम वीडियोस के अंदर डिस्कस करेंगे। तो सबसे पहला जो टॉपिक हम आज लेके चल रहे हैं, दैट इज ग्रेडियंट ऑफ अ स्केलर फील्ड। ग्रेडियंट ऑफ अ स्केलर फील्ड। सो ग्रेडियंट ऑफ अ स्केलर फील्ड के लिए आपको क्या करना है, कुछ ज़रूरी बातें हैं जो आपको सीखनी है। सबसे पहले इसमें एक डेल ऑपरेटर होता है, डेल ऑपरेटर, और व्हाट वी से इट एज nebula. Another name for this del operator is what? Nebula. And we are taking this phi which is depending on x, y, z. It is a scalar function. Means to say no vectors are involved for this function, that's why we are saying that it is a scalar function. So what we have to do, we have to find the gradient of this scalar function phi. So first of all we write the value of this del, that will be I del by del x plus j del upon del y plus k del by del z. So if we operate this del on this scalar function phi, so what we are getting, del phi is equal to I cap curl by curl x plus j cap curl upon curl y plus k cap curl by curl z of this phi. So in short we are writing this phi x by z is only phi. So what we are getting here, it is I cap curl phi by curl x plus j cap curl phi by curl y plus k cap curl phi by curl z. So dear students, this is the value of this del phi, that is what we are saying, it is del phi, or what we are saying, gradient of phi. So in short we write it as grade phi. So this is the formula according to which we can find the gradient of a scalar function. So we are taking one question for this gradient of scalar field. So let us take the statement, if we are having this phi x y z is equal to, we can take it as x square y minus y cube z square. Then we have to find del phi at which point, at suppose we are taking 1 minus 1 and 1. You can get any scalar function from here, and then you have to find this gradient of phi at which point, any point. Just here we are taking it as 1 minus 1 and 1. So how we can compute the gradient of this function phi? So we operate del on this phi. So apply this formula, it is I cap curl by curl x of this phi. This phi means to say x square y minus y cube z square. Then it is plus j cap curl upon curl y of this again phi, that is x square y minus y cube z square. And last it is k cap del by del z of x square y minus y cube z square. So if you solve this, you get I cap. So we differentiate this x square y minus y cube z square partially with respect to x. So this whole term is constant, so we just differentiate this. So what we are getting, 2xy, because y we are keeping constant, derivative is with respect to x. Similarly come to the second term, here it is del upon del y, so the derivative first term is x square and it is y cube z square, so we are getting 3y square z square. And last one is j cap, it is del by del z of x square y minus y cube z square, so again it is 0, so we are getting it as minus 3 minus 2y cube z, because again y cube is constant and derivative of z square is 2z, so it is minus 2y cube z. But we have to find del phi at which point? 1 minus 1 1. So what we put here now, x we put x equal to 1, y equal to minus 1 and z equal to 1. So del phi at which point? 1 minus 1 1 equal to, so put the values of x y z in this term. So it is 2xy, x is 1, y is minus 1, so it is minus 2 I cap. It is x square, that is 1 square, minus 3, 1 square, 1 square, so it is 1 minus 3, again it is minus 2 j cap, and last one is what it is j cap, so it is y cube we get minus 1, z is 1, so it is plus 2 sorry, it is k cap, so 2 k cap. So we are getting the answer minus 2 I cap minus 2 j cap plus 2 k cap. So this is the answer in which we have to find the gradient of phi at which point? 1, minus 1 and plus 1. Hope so you understand this problem and something about this gradient of scalar field. So in the next video I will solve some very important examples related to your exams as well as for competitive exams. So keep watching our videos and don't forget to subscribe our YouTube channel Shiv Academy of Mathematics. Thank you.